Hello everyone, welcome back to my old students and to my new ones. Hopefully you all get something out of this new video. To all my old students, I've made a video like this previously, but as hopefully you can hear, I've got a new mic, so I'm trying it out. But also I'm trying to do something a bit more visual so it can help you understand balancing chemical equations. Now for my new students, and especially the ones who missed classes earlier on in the week, this video should help get you up to speed or help you clarify some issues when it comes to balancing chemical equations if you didn't quite get it the first time around. So why do we even bother balancing chemical equations? Well, the law of conservation of mass states that what goes into a reaction must come out in some way. Mass is neither lost nor gained. It is not created or destroyed. This means that any element that enters a chemical reaction as part of the reactants must somehow be present in the products. So if you put in a carbon atom, it is not going to turn into an oxygen or a hydrogen through the reaction. It is also not going to disappear into thin air or appear out of nowhere. So every element that goes in must also come out. Now, taking this a step further, not only do the same elements have to go in and out, but also the same numbers of every element. So the numbers of atoms in the reactants must also equal the number of atoms present in the products. Now, for this reason, we balance chemical equations so we can show accurately exactly what atoms are going in and which atoms are necessary in order to form a complete set of products. Now I'm going to start with one of our standard reactions we've seen a few times, which is our good old hydrochloric acid and magnesium. Now from our earlier experiments using the POP test, you should hopefully remember that this reaction produces hydrogen gas, which exists as a H2 molecule, not as individual atoms, and it also produces aqueous magnesium chloride. Now if we actually build up these reactants and products, you can actually see the atoms that are going in and out of the reaction. Now we've got one thing, right, that on the left side with the reactants we have hydrogen, chlorine and magnesium, and we also have the same elements on the right hand side. However, if we actually try to make the products out of the atoms available in the reactants, you're going to see that we're not going to be successful. We don't have enough hydrogens to make a complete hydrogen molecule, nor do we have enough chlorines to make a complete magnesium chloride. So clearly something has to change here. So what we're going to do is we're going to add the atoms we need. We cannot just simply add atoms like taking them out of a hat. We have to add the actual molecules that contain the atoms we need. So in this case, we actually need more hydrogens than chlorine, and they both happen to exist in the hydrochloric acid molecule. So if we add an extra molecule and now we actually start this reaction off with 2 hydrochloric acid molecules and 1 atom of magnesium, we'll see here if we try the same trick again to actually build our products from the new set of atoms available to us, we can successfully make the hydrogen molecule because we now have enough hydrogens. We can also make the magnesium chloride because we have enough chlorines. So in order for this reaction to be balanced, we have to start with 2 molecules of hydrochloric acid and 1 atom of magnesium to produce a hydrogen molecule and a magnesium chloride molecule. Now please note the 2 in front of the hydrochloric acid formula. The 2 in front means 2 molecules, 2 of everything inside the molecule. When we're balancing, we can't actually change the formation of molecules themselves. So see here how we've got a 2 at the back of the magnesium chloride. That stays fixed because the magnesiums and the chlorines are physically bonded together. Changing that 2 to a 3, for instance, would mean adding an entire atom to that molecule, which is something we can't do. We can only multiply the number of molecules already available to us. Now I'm going to start with another one. This one's a bit bigger, but in a way a little bit simpler because we've only got 2 elements to think about. We have nitrogen and hydrogen. I'm going to do this using our number method because it's the way that you're going to probably do it in a test. And funnily enough, some people find this way easier than actually drawing out and fiddling around with models. So to start with, we have 2 nitrogen atoms and 2 hydrogen atoms on the left, and on the right we have 1 nitrogen, 3 hydrogens. So clearly you can see that we actually have 1 fewer nitrogens in the products than we actually need. One thing to keep in mind, you always add to chemical reactions, you never take away. Taking it away, if we took away a nitrogen, we'd somehow take away all of our reactants and the reaction wouldn't go at all. Always add, keep on adding. So in this case, we are going to add an ammonia molecule, which is the NH3, and so we're going to have a total of 2. Every time you add something to an equation, you have to update your count to make sure you're on the right track. So in this case, now that we have 2 ammonia molecules, we now have 2 nitrogens and 6 hydrogens in the products. Our nitrogens are balanced, but our hydrogens now no longer are. So we have 6 in the products and only 2 in the reactants. So if we now have, instead of 1 hydrogen molecule, we now have 3, that gives us a grand total of 6 hydrogen atoms in the reactants. And if you look at our numbers on the left and on the right, we now have equal numbers. So if we are to perform this reaction in a balanced way, so that everything reacts properly, we have to use 1 molecule of nitrogen and 3 molecules of hydrogen, which will produce 2 molecules of ammonia. Now this last example is a bit bigger because we've got quite a few more elements to look at. We have lithium, oxygen, hydrogen and chlorine, which of course is present on both sides but in different numbers. You'll see that we don't have the same number of lithium atoms and we also don't have the same number of chlorines. So for the first thing we're going to do, to balance things out, we're going to make our numbers of lithium atoms equal. There are 2 lithium atoms in the reactants, so we are going to put 2 in the products, and to do this we need to add an entire molecule of lithium chloride. Now when we add the entire molecule, we now have 2 lithium atoms, but we also have 2 chlorines. Always make sure to double check your counting. Now we're almost balanced, but now we've got an extra chlorine atom in the products, but we also have an extra hydrogen. Luckily for us, both of those atoms are present in the hydrochloric acid molecule. So if we add another hydrochloric acid molecule by putting a 2 in front of it, we now have 2 hydrogens and 2 chlorines on both sides. We also have 2 lithiums and 1 oxygen each. So everything's all balanced and ready to go. So thanks everyone for listening. Hopefully this video is helpful. I'll be putting a link to this in my OneNote and also on my YouTube channel. If you've got any questions or queries, comments or complaints, please let me know either directly in class or in the comment section of YouTube. Bye!